Question number 13 from current electricity. Here question is, if a copper wire is stretched to make it 0.1% longer, what is the percentage of change in its resistance? See, first I should tell you here wire is stretched. When a wire is stretched from both sides, then its area of cross section will reduce. That means area will decrease, and also as it is stretched, that means length will increase. That means L1 to L2, where L2 should be greater than L1, and A1 to A2, where A1 should be greater than A2. Okay, then for both the case, the resistance of the resistor should be increased, because we know resistance equal to resistivity into L by A. That means resistance is proportional to L and inversely proportional to A. As here L is increased, that means its resistance also increase, and A is decreased, that means it again contribute to increase the resistance. We have to calculate the final resistance after stretching 0.1%. Now see, let initial length equal to L, okay, and that is equal to L1. Okay, so when it stretched 0.1%, its final length become let L2, and L2 should be equal to L plus 0.1% of L, because this much is the increase in length, right? So I should write L plus 0.1 by 100 L. This is equal to 1.001 L. This will be the final length of the wire. Now when length is increasing, area is decreasing. Already here I have told, as length is increasing, area is decreasing, but volume should be constant. That means V1 should be equal to V2, because V is equal to volume equal to area into length. If L is increased, then A should reduce to compensate the volume at fixed value. So I should write, during stretching volume should remain constant. That means V1 should be equal to V2, where V1 equal to A1 into L1, because it was the initial volume, and V2 equal to A2 into L2. Now A2 equal to A L2 equal to 1.001 L. So I should write A2 into 1.001 L, and here I should write A1 into L, because initial length was L. Now let initial resistance equal to R1 and final resistance equal to R2. So R1 should be equal to rho into L1 by A1 and R2 should be equal to rho into L2 by A2. As the material remain constant, so rho will not change. Okay, now this is equal to rho into what is L2? L2 means 1.001 L by A2, right? And E1, this is equal to, I could write rho into L by A1, right? And as V1 equal to V2, so I should write A1N is equal to A2 into 1.001 L. That means A1 equal to A2 into 1.001. That means when R1 by R2 you could get rho L by A1 into rho into 1.001 L, here it is A2. This is equal to rho and L will cancel out, and A2 equal A1 A2 by A1 equal to 1.001 A2 into 1.001, and this will cancel out. It become 1 by 1.001 whole square. That means R2 equal to 1.001 whole square into R1. It is approximately equal to 1.002 R1. So now here question was find the percentage of change in resistance. See, the change in resistance in percentage equal to R2 minus R1 by R1 into 100%. This is equal to 1.002 minus 1.002 R1. I have to write 1.002 R1 because R2 is equal to 1.002 R1 already I have calculated, minus R1 by R1 into 100%. This is equal to 0.002 R1 by R1 into 100%. R1 and cancel out. This is equal to 0.2%. This will be the answer. Okay, that means if a resistance is in stage 0.1% longer than earlier, then its resistance will change 0.2%, then 0.2% more than earlier. Okay, now I will go for next numerical.